Hello everybody, I am Veronica Shalamanova. Today I'm going to talk about right circular cylinder. So, let's start by giving it a definition. A solid object that is obtained by rotating a rectangular around one of its sides is called a right circular cylinder. The elements of such cylinder are two pairs of bases which are parallel, axis of revolution, radius of the base, which we mark with R, generator, which we mark with L, height, which we mark with H, lateral area, which we mark with S, and if we cut the lateral area of a cylinder along the generator AB and unfold it in a plane, we will get a rectangular with sides with the length of the base of the cylinder and the generator, because all of the generators are with the same length. This rectangular is called axis intersection, and as you can see, its sides are with lengths 2 times pi r and L. Now that we know what a right circular cylinder is, let's move on to the formulas. The lateral area is equal to the area of the axis intersection, which means 2 times pi times r times L. The total area of the cylinder equals the sum of the area of the two bases and the lateral area, which is 2 times pi times r squared plus 2 times pi times r times L. And here is the abbreviated version. The last formula is the formula for the volume, which is the area of the base times the height, or in other words, pi times r squared times h. Now we can move on to the problems. Problem 1. Given is a right circular cylinder. The ratio of the area of the base to the axis intersection of the cylinder is equal to pi divided to 4. Find the angle between the diagonals of the axis intersection. We will start by saying that the axis intersection ABCD is a rectangle, and we should find the diagonals of ABCD. I am drawing them with green, and here they cross in point G. We should find this angle right here. We would call it alpha. We know that the ratio of B to SABCD is equal to pi divided to 4. The area of the base is equal to pi times r squared, and the area of ABCD is AB multiplied by BC. But we know that AB is equal to 2 times r, so the area of ABCD is equal to 2 times r times BC, which is basically the height h. This is equal to pi divided to 4. We remove the two pi's, and here r and r squared. Now we have r divided to h, which equals 1/4. From here, we can make the conclusion that the height h is equal to 2 times r. So BC is equal to 2 times r. As we can see, AB also equals 2 times r. This means that ABCD is not only a rectangular but also a square. We know that in a square, the diagonals are mutually perpendicular, so the angle alpha, which we have to find, is equal to 90 degrees. And this is the end of the problem. We move on to the next one. A rectangular with sides A and B, where A is larger than B, rotates consecutively around the line of symmetry of each side. Which of the two cylinders have a larger volume? If the height of the cylinder is B, the radius of the base would be equal to A divided to 2. Therefore, the volume of the first cylinder, V1, equals pi times r squared times h, which equals pi times a squared times b divided to 4. But there is a second cylinder. If the height of it is equal to a, the radius of the base would be equal to b divided to 2, and the volume, V2, would equal pi times a times b squared divided to 4. We will compare the two volumes by finding their ratio. V divided to V2 equals a times squared times b times 4 pi divided to 4 times b times a times b squared. And when we simplify this equation, we are left with A divided to B, which is greater than 1. Hence, the cylinder with height B has greater volume than the cylinder with height A. And this was the end of this problem. As you can see, these problems are much easier than those about prisms and pyramids. So, I hope this presentation was helpful, and I hope that everything is cleared up by now. Thank you so much for your attention. Bye!